Welcome to Mastering Machines, where we discover tomorrow's reality.
You hear so many people talk about GPU cluster this, GPU cluster that in relation to AI talks and AI articles. But in this video, I wanted to break down what exactly is a GPU cluster. Before we go into what a GPU cluster is, let's talk about what just a GPU is. GPU stands for Graphics Processing Unit. Once primarily associated with just gaming, the Graphics Processing Unit, or the GPU, has evolved into a cornerstone of what we consider the modern computing world. Its parallel processing architecture, originally designed for 3D graphics rendering, now drives a diverse range of applications across personal and business computing landscapes, i.e., AI and AI infrastructure. The GPU's journey began with accelerating graphics and video rendering, but its programmable nature soon unlocked a bigger potential. Graphics programmers leveraged this flexibility to create increasingly sophisticated visual effects, and that included advanced lighting, shadowing techniques, and a lot of these techniques that we see in video games and movie special effects. But now the use of the GPU has expanded to more sophisticated creative production, and of course AI and AI infrastructure, and then also high performance computing. The adaptability of GPUs has allowed developers to harness that power for complex computational tasks, and it goes just beyond using it for special effects or graphics. Because of the power of the GPU, it has become a focal point for the AI world and the AI infrastructure. When you hear people refer to compute and computing within the AI kind of lexicon, it's because of GPUs and how they're able to be scaled up and be able to be used within the AI world at mass scale. So what exactly is a GPU cluster then? Well, imagine taking the power of a single GPU and multiplying it many times over. That's essentially what a GPU cluster does. It's a collection of multiple GPUs working in tandem, often housed in a specialized data center. This is why NVIDIA is such a huge company right now, is because they are able to leverage their GPUs and use it for these huge GPU clusters, like how Elon Musk has used it with X to create a GPU cluster within 19 or 20 days, when it's usually a year to actually create that. These clusters can contain hundreds or even thousands of GPUs, all interconnected to form a supercomputing powerhouse. The key here is parallel processing, the ability to perform multiple calculations simultaneously. While a single GPU is already adept at this, a cluster takes it to an entirely new level. Now let's connect the dots between GPU clusters and AI. The field of artificial intelligence, particularly deep learning, relies on processing vast amounts of data to train these complex AI models. This is where the GPU clusters shine and are really able to be implemented and expanded. Training an AI model is like teaching a child. It requires repetition, pattern recognition, and learning from its mistakes. But instead of years, we want the AI to learn in days or even hours. So GPU clusters make this possible, dividing the workload across multiple units. For instance, when training a large language model like GPT-3 or 4, the neural network can be split across multiple GPUs. Each GPU might handle a portion of the model's layers or process in a subset of the training data. The distribution allows for much faster training times and enables the creation of larger, more sophisticated models. Let's zoom out and look at the bigger picture of AI infrastructure. GPU clusters are a critical component of this, but they're only a smaller part of a larger ecosystem. This ecosystem includes high-speed networking to ensure rapid communication between GPUs and data storage, specialized cooling systems to manage the intense heat and energy that's generated by these powerful processors and the tasks that they're completing, software frameworks like TensorFlow or PyTorch, which optimize the distributed computing across all these GPU clusters or one GPU cluster. And then there's the data storage solution, which is capable of feeding data to the GPUs at speeds that they require. Many companies that are invested heavily in AI are also deeply invested into GPU clusters such as Meta, OpenAI, and X that are spending hundreds of millions of dollars a year to basically train up these AI models using these large GPU clusters that cost sometimes $100 million. But it's not just about the raw power. The real art lies in efficiently orchestrating these resources. AI researchers and engineers constantly work on optimizing how tasks are distributed across the cluster, ensuring maximum utilization and minimal bottlenecks. Hopefully, you've learned a little bit more about how GPU clusters work and how they're related to the AI world. I like to compare the current AI boom to the gold rush of the 1800s, because not only was there tons of wealth being generated via the gold that was being mined, but there was tons of wealth generated by the pickaxe shovels that were sold to the people mining the gold. And that's what a lot of companies like Nvidia and AMD are doing, is selling these GPUs and basically being the pickaxe shovels of 2024. Remember, mastering machines, discover tomorrow's reality.